What's up guys? In this tutorial, I'm going to walk you through what is exactly a linked list data structure. So before we start with linked list data structure, we should really see about the arrays which we have seen previously, right? So let's say that you are defining an int array, and I'm going to name this is array as, let's say, numbers. So I'm actually defining here an int array with some values, let's say 1, 2, 3, and 4. So basically these values, when you define an array in Java, so what happens is, let's assume that this is your memory block. Just spare me for this bad drawing. And this is your memory block, right? Let's say that this is at address 0, this is at address 1, this is at address 2. Likewise, it is incrementing. So when you define an array in Java, and this array is basically having these numbers are actually stored in memory blocks. So whenever you declare an array, these numbers is actually stored in a contiguous memory block. So what does this mean? So let's say that if one is at, let's say, at address 1, so 2 3 4 will be at address 2 3 4 sequentially, right? So this is why whenever you are getting, let's say, if I'm getting the numbers at index, let's say 2, you'll this operation is basically happens in O of 1. The main reason is this array is actually stored in a contiguous memory blocks, and we already know the address of those memory blocks internally. So this operation, whenever we get a value based on an index, the operation happens in O of 1. So this is an array. This is the whole concept of array. Whenever you declare an array, it actually, the elements are stored in a contiguous memory block. Now, coming back to what is a linked list data structure. So I'm showing you inside this, right? And I'm going to have, so what is exactly a linked list? So for example, a linked list, I'm going to draw a box here. Again, spare me for bad drawing, right? So this is where your data will have, along with the data, it has a pointer, right? A pointer p1 for the next data in a linked list. So basically, a linked list is a linear data structure. It has a data stored here. Along with the data, it also has a pointer that points to the next data, right? So this is basically, if I draw a memory block here, for example, right? And if I draw here some memory block, and let's say have this dot here, and I have one more memory block here. So for example, if your data d1 is stored here at, let's say, at the first memory block, the d2 will be stored somewhere around, let's say, at dn, right? So d2 will be stored at dn. So it's not guaranteed that this will be stored in a contiguous memory blocks. Rather, it's stored arbitrarily anywhere inside the memory. So what happens is, these pointers actually help you. Let's say that D1 is stored here, right? So as linked list, it's actually a list data structure. So the data is actually stored in a list format. So for example, if a linked list is of type integer and I have a value 1, 2, 3, 4. So if 1 is here, maybe 2 will be here and 3 will be somewhere. So how do we know that? How do we get the value of 2? So we can get the value of 2 through this pointers, right? So this is called as a pointer. In short, it's actually called as a node, and this is called as a head. The first data is called as a head, and then we have a pointers to the next data as well. And this is the linked list data structure, right? So this is what the linked list data structure is all about. Let's say that you want to get a data at position n, right? So you have a list up to, let's say, that 1 comma 2 comma 3 comma up to n, and you want, let's say, at some position, arbitrary position k. So as these elements are stored arbitrarily inside a memory, you have to actually iterate through this list till you find that value, right? So once you find that value, you return the value here. So the operation of getting the value at specific index, it's big O of n. So this is actually linear time, right? So if you let's say that you have a requirement where you are making a lot of get requests, linked list is not your ideal choice. It should be array list. But if you want to manipulate, right, if you want to manipulate your data and like you want to add or remove, you can use linked list because it provides a good performance, a better performance. Also, whenever you add like let's say that you have an array list and the default size of an array list is 10, right? Let's say you try to add the 11th element. So what this array list will do is it will actually resize, and then it will add the 11th element, right? But linked list, that's not the case. The linked list can start from the first index itself. It doesn't have a default size. It can grow dynamically. That's why the linked list is also a dynamic array, right? So this is all about linked list. In the next tutorial, I'm going to start with the linked list implementation. So I'll catch you up in the next tutorial.